The last concept that we need to cover for subtopic 2.2 on waves is intensity. Now intensity applies to all waves, so we need to mention that it's a measure of brightness for light waves, and it can also be considered in the context of sound waves, but in that case it's about how loud the sound is. So they're the two contexts in which intensity applies in what we're looking at. More specifically, we only really need to deal with light waves, but the same idea applies whether it's sound or light. The definition for intensity, though, is that it is the rate of flow of energy per unit area. So let's have a look at what that means in more detail. We're going to do that considering a diagram. So imagine we have a light bulb sitting here, and that light bulb is going to be radiating light from it, as is obviously the case. So light rays will be travelling off in all directions, and so moving into the space around it and producing light waves from that source. Now the source of the light itself is going to be converting energy from electrical energy to light energy at a certain rate, and we can measure that using the concept of power. So power is the rate at which energy is being converted per second. Now that idea will come up again when we look at electric circuits, so I won't go into it in too much detail now, but just be aware that power is the rate at which energy is being used. So if we look at that definition for intensity, then we can identify that the intensity, I, is equal to the rate at which energy flows through a particular region, so that's going to be P, divided by the area that we're dealing with. Now if we consider this situation, we're going to look at an area that's some distance away from this light source, and it's going to be the area of a section of a sphere. So that is the area that we're going to consider. So just representing that as a shaded surface. The area that we're really dealing with is going to be the area of a sphere. So like I said, we're only looking at a section of the sphere there, but for a sphere the area is given by 4 pi r squared. And so we need to know what the distance is, or the radius, from that light source. So we can then identify that the intensity is equal to P over 4 pi r squared. So that's how we would calculate the intensity if we knew what the power of the source is and what the distance to the point of observation is as well. So the intensity here is measured in watts per square meter. P is the source power, so this, the power of the light source in this case, and source power will be measured in watts, and R is the distance from the light source. And that will be in meters. So there's an equation for us to calculate intensity. It's a little bit easier than that for what you need to know. We don't actually need that equation in any great detail. What you do need to know though is that the intensity is therefore inversely proportional to the square of the radius. So we can take that from the equation above, where if we take the power of the source as a constant value, and we know that 4 pi is constant as well, we can then identify that I is proportional to 1 on r squared. So a way to interpret that then is that as the distance from the source increases, we're going to see a change in the intensity. So that distance being that value of r, the intensity will decrease with the square of the distance. And to explain that in a little bit more detail, as an example, imagine we start off with that diagram that we've got there. If we double that distance, so we're going to go to a distance of 2r, the area that we're going to deal with there is now actually going to be 4 times as big. So this new area that we're dealing with, and keep in mind that's just representing a section of the sphere, that's going to be 4 times the area. And since I is equal to P over A, if A has increased by a factor of 4, then I will decrease by a factor of 4. So, as an example, if R doubles, so in other words R is increasing by a factor of 2, I will decrease by a factor of 4. So whatever the increase in R, I will decrease by the square of that factor. So doubling results in a decrease by a factor of 4, tripling would result in a decrease by a factor of 9. So there's intensity. There's a lot more that can be said about intensity, but as I said, that's the detail that you need to know for this syllabus. So the fact that intensity is inversely proportional to the square of the distance.